Hello again, it's Cliff here from Down Under. How you all doing in this crazy world we live in? It's depressing to watch the news at the moment. What's going on in the States and what's going on in the UK? I'd rather be down in the workshop. In this video I want to go into broken tap removal, how to remove a broken tap, and how to avoid breaking a tap in the first place. So in the first part of the video, I'll go into different ways that you can remove a broken tap, and at the end of the video, if you can hang out to the end, I'll show you ways to avoid breaking a tap. You never should break a tap with the correct procedure. I broke a tap many years ago and I learned my lesson the hard way. Prevention is better than cure. Okay, so let's say you've broken a tap, disaster of disasters, and you want to get it out before the boss finds out. The first thing you want to try and do is unscrew it. And obviously, the bigger the tap, the more chance you've got of that. So if you get something like a center punch, let's just zoom in on this a little bit. And try and shift it. Just try and tap it at that point there. On each of the flutes, and see if you can turn it. If you can move it, that's a good sign. There's a chance you'll be able to unscrew it. And if you can move it and it's up near the top, and obviously if it breaks deep down inside the thread and it's well below the surface, you're in serious trouble, and you've either got to throw the part in the trash or get it spark eroded out. But let's say it's up near the top and you're able to shift it slightly. And you can see, well, this could come out. Then you can make a little unscrewing tool. You can actually buy these. I don't know how readily available they are, but this is a kit made by Walden Tools that is suitable for a range of 4 flute taps. And you can slip this down into the gaps between the teeth and lock up the little ring, which sort of tightens the collet onto it, and hopefully unscrew it. But if the tap is below 1/4 of an inch in diameter, that's going to be a big ask and you might not be able to do it. But let's say it's a 1/4 inch tap, it's borderline, but it's a 3 flute tap. Well, what you can do, see if I can show this here, is you can make a special extracting tool. Let's zoom in a little bit more. So what we have there is 3 little flutes that go down into the gaps between the tap. Now, you can't just use any old material for this. It needs to be a very high tensile steel. You could possibly use a cap screw and turn it down in the lathe and drill a little hole, the core diameter of the tap. But even better would be to get a piece of an Allen key. You call them hexagon keys or Allen keys. Cut it off in the grinder, put that in the lathe, turn it down to the hole inside the broken tap hole, drill a hole in the middle to the core diameter, and then file or grind little flutes so that you have a very strong steel tool that you can insert in around the broken tap. Let's just show that now. What we got we can show. Here's a little 6mm tap, and there's a tool I've made to remove a broken tap in the past. Sometimes people bring me broken taps to spark erode it out, and the first thing I do is have a go at removing it with an extractor like this. And so if it's near the surface and you can tap it and get it to move, then it's worth making a little tool like this and tapping it down well into the flutes and carefully, with a bit of downward force, unscrewing the broken tap out. And you may need to file or grind that with a little slitting saw or a Dremel to fit either a 4 or a 3 flute tap. Now that won't work if it's a tiny tap of 3mm diameter, because the problem becomes exponentially impossible as these little flutes on your tool become weaker and weaker. But above about 1/4 of an inch, it's likely that you could be successful. Broken tap in an expensive part. It's a nightmare we all dread. We've all done it. I did it many years ago when I was learning the trade of tool making, and I broke a tap in an expensive die, and the lesson was so painful I've been careful ever since, and I don't think I've broken very many taps since that first painful lesson, because they're so difficult to get out. This one is a 5mm tap broken deep down inside this hole. The client has brought the part in to have the tap removed because it's a valuable part and he wants to save it. I won't disclose the details of the part or the client because I'm not sure about the IP and I don't want to embarrass him anyway. But I'll go through removing this broken tap now, and should be quite an interesting subject. Removing a broken tap with a spark eroder is actually not always an easy process. I mean, obviously the idea is that you put an electrode in and erode down through the middle of the broken tap to remove the solid core, and then you can just flick the little broken pieces of tap out of the thread. And that sounds really quick and easy, but the problem is that the tap's often shattered in little pieces, and as you move down, the little pieces become free and start to short out the tap and interrupt the spark eroding process. And then you've got to retract the electrode and drain the fluid and try and remove the little piece of broken tap, and then go back to where you were and cut down another millimeter or two, and the process can actually take quite a long time. And so I've got no idea how this is going to go. Alright, let's fire it up. Usually goes well in the beginning when the tap is fairly structurally sound. You can see the progress here on the dial indicator. It's not cutting too bad, it's progressing reasonably quickly. I've just got it on 6 amps, high voltage. Not getting too carried away because it won't take long to cut through if it goes well. It's all about whether or not the little particles of tap start to come free and short out the process. Well, it's going really well, touch wood. It started shorting out and I had to pull the part out and blow it out with compressed air and try and flick out some little pieces of broken tap, set it up again, and it's been going really good now. It's gone down a long way. That's at 6 amps, 200 volts roughly. It's just starting to fault now. It might be breaking through the bottom, so I better have a look at it. Well, that went reasonably smoothly. I've got the threaded hole back now, and the thread is reasonably in good condition. There's a little bit of damage at the top where the mechanic tried to remove the broken tap with a center punch by the looks of it, but that's only down 1 or 2 millimeters, and then we get below that and there's a good thread there. So that was quite successful. It went quite smoothly. But you can't quote for a job like this. You daren't quote a fixed price. You know, I just said, well, it just depends on how it goes, because it can literally take anywhere from half an hour to half a day to spark erode out a broken tap. So let's have a look at the pieces. There's the center core, and it's a 3 flute tap and the 3 little segments of flute that I picked out of the sides. 3 flute tap, something like that. So you can see it's a piece of broken tap in there about, how deep is it? 8 or 10 millimeters deep. And good tools to remove it are a scriber and a strong magnet, and obviously compressed air to get the little pieces out. I had to do that once and then go back down, although I don't think I actually removed them. I probably just shifted them enough to jam in place, and then allow the spark eroding process to continue without them moving around again. But you know, sometimes that doesn't go like that, and the little pieces flop around and short out, and they won't come out, and they jam in place. As soon as you start eroding again, they start shifting and shorting, and it can be a real battle. You probably need to remove the part each time and set it up, and you're getting atomized dielectric fluid with the compressed air blowing in your face, and it's not a simple solution. It can go well, but it doesn't always. While I'm on the subject, because I had to tap out the threaded hole to make sure it was clear, if you need to tap in that situation where there's possibly little pieces of hardened thread, or you need to tap hardened steel and you don't want to damage your nice new sharp tap, what you can do, and I've done this many times over the years, is get an old tap that's blunt and grind the end of it off, you know, maybe 1/4 of an inch off the end, just square off on the bench grinder until you've got fresh, clean cutting threads, and then grind a chamfer of about 30 or 45 degrees with a little bit of a back off angle. Can you see that there? So that it's clearance. And then that sounds very crude, but if you're careful, you can grind an old tap back like that and it will cut like new. It will cut really well. And if you're struggling to tap a tough piece of steel, just do that with your tap. Look at it closely with a magnifying glass. The cutting edges are likely going to be slightly rounded, and so what you're doing is not cleanly cutting the metal, but you're sort of trying to form the metal with a blunt edge, and that takes about 2 or 3 times as much torque to cut as it does with a razor sharp edge on the tap, and 2 or 3 times on a borderline steel and a borderline tap will mean a broken tap. So use just enough torque that you're comfortable with, and stay clear of breaking the tap. And if the tap stalls and it won't go any further, remove the tap, look at it closely with a magnifying glass. If it's slightly dull on the edge, grind a hole 1/4 of an inch off the end and cut new chamfers with slight clearance on them so it's cutting on the cutting edge. Go back in, and with the same degree of torque, you'll find the tap with a bit of cutting oil will race ahead and cut cleanly, and you don't need to risk breaking your tap. So that's the number one tip here. Make sure your tap is razor sharp, and you don't have to buy a new tap every time. You can refurbish an old tap. So this tap was just an old tap ground back with a new chamfer cut on the end, so I didn't have to worry about chipping it on the little pieces of hardened tap inside the thread. I could tap happily knowing I'd only be damaging a tap that was already 1 step away from the rubbish bin. In this video I've stated that if the tap is below 1/4 of an inch and won't move and it's seized in place, that you'll have a great deal of difficulty removing it. Actually, I should say it is possible to remove smaller taps by this method. I have removed taps by this method down to about 4 millimeters, but it is quite difficult, and you need to get all your ducks in a line. You need to get the approach really carefully thought out. If the tap is seized in there and it's well below the surface and it's below 1/4 of an inch, you can get it out with a very hard, strong, well-made extractor tool and the right technique, but it becomes increasingly difficult below 1/4 of an inch, is really what I should say. Well, that's probably enough for now, isn't it? Catch you next time.